Okay, so this is example 39. We will do A and E in this first part, and in the second part we will do F. Okay, so in the diagram alongside the graph of F, a hyperbola, and g of x, 2x minus 4 are shown. So they make mention of this graph's name, hyperbola, which has the standard form y is equal to a over x plus q. Okay, so I'd write that down for myself. And then they give us the equation of g of x over here. Okay, and they're saying that g of x is 2x minus 4. Now with that information, you now have the y-intercept at minus 4, right? And I want you to just keep in mind the fact that the y-intercept of g is also the point where our asymptote is passing through. And so there's that connection between those two things, okay? Now that we filled in as much as we could, we need to determine the coordinates of A. And if we have a look at A is the point of intersection of F and G, okay? But we do not have the equation of F, and so that's not a feasible option. Alternatively, A is also the x-intercept of G and of A, but because G is the equation that was given to us, right, we can use G to determine this x-intercept. So now we get the x-int, right, by letting y be equal to 0. Then we say 0 is equal to 2x minus 4. Therefore, negative 2x is equal to negative 4, meaning x is equal to 2, right? That means that A would be at 2 and 0, and that is the very first answer to the first question, right? So again, A is the x-intercept of both graphs, but we only have the equation of G, and so we substituted into G and found A to be at points 2 and 0. Alright, so the next question here is to determine the coordinates of C. Okay, and so lucky for us, we already filled in as much information as possible, and so therefore point C over here is just going to be at 0 for x and minus 4 for y, right? And so now that one is also completed. The next question is to determine the equation of f. Now in the beginning, and I've erased it now, we wrote down the general or standard form for hyperbola, which was y is equal to a over x plus q, right? And so now we want to find the equation of our red graph, which is our f function, okay? And so if we take the equation y is equal to a over x plus q, we just start filling in what we can, right? So what was given to us earlier was this little asymptote of our hyperbola, and so now the equation would be y is equal to a over x minus 4. At this point you have 1, 2, 3 variables, and you can easily solve for a by substituting a point. So we will substitute this yellow point A, seeing as it does lie on our f function. So we will substitute 2 and 0 into our equation, and it will look as follows. Okay, so 0 is equal to a over 2 minus 4. What we can do is we can bring the 4 over, and we have a over 2. When we cross multiply, we end up with a equal to 8, and so therefore f of x is going to be 8 over x minus 4, and that is the equation of our function f. Okay, so the next task we are faced with is to determine the coordinates of B, and B is a point of intersection between F and G. So we now have the equations of both F and G in purple and in red, and so we need to figure out the points where f of x and g of x are equal. Now bear in mind, we already have the one point A, which we know is at 2 and 0, and so now we need to figure out point B, And the one thing we do know about this point is that the x coordinate is negative. So now we just substitute our equations. Alright, so now we have 8 over x minus 4 equal to 2x minus 4. I would multiply each term by x so as to eliminate this denominator. So when I do so, I end up with 8 minus 4x equal to 2x squared minus 4. Now this looks like a trinomial, and so I'm going to bring everything to the left hand side so that I end up with 8 minus 4x minus 2x squared plus 4 all equal to 0, and this simplifies down to negative 2x squared minus 4x plus 12. Okay, now at this point we need to have our coefficient of x being 1, so I'm going to divide all the terms by negative 2 so that I end up with x squared plus 2x minus 6. Okay, and now that I have this quadratic trinomial, which we've now encountered a few times, we need to factorize in order to find our different answers. And so the factors of 6 that can produce a 2 would be 3 and 2, right? And so we can say x plus 3 and x minus 2. That would mean our solutions are x is equal to minus 3 or x is equal to 2. Now at this point I get very happy because x equal to 2 is one of the solutions that we know, because that is the POI at A. And so because one of the solutions that are known to us are appearing in our set of solutions, we know that we have done the right thing. Alright, and so that would now mean that the x coordinate of B is at negative 3, and in order for us to get the y coordinate, we either substitute the negative 3 into our f equation or our g equation. I always go for the straight line equation, and so using minus 3, if we just do a bit of mental maths, when x is minus 3, right, we end up with negative 6 minus 4, which is negative 10. Okay, but we can write it down over here on the bottom right. We can say that y is equal to 2x minus 4 is equal to 2 times our negative 3 minus 4 to give us that answer of negative 10, right? And so the coordinates of B is at minus 3 and at 10. Okay, so question E says, write down the equation of the axis of symmetry of F. Now let's pause there. There are two axes of symmetry. We have the one where y is equal to x plus q, and we have the one where y is equal to negative x plus q. Okay, now that we know that, the rest of the question says, write down the equation of the axis of symmetry that has a positive gradient. Okay, so that narrows it down. They want the one with a positive gradient, which would be this one. Okay, because remember, if y is equal to mx plus c, the gradient here is a positive one, and the gradient for the one we don't want is a negative one, right? So now that we know that, we are using y is equal to x plus q, right? And we already established that q is over here at minus 4. Okay, and so on the topic of the gradients, this is the one with a positive gradient that's kind of going up, that's going upward, increasing, and this is the one with a negative gradient, but we don't want that one, right? So let's just erase the unnecessary stuff. Okay, and so now we know that q is at negative 4, and so the equation of this line is simply y is equal to x minus 4, and that's it. And so this purple line has the equation y is equal to x minus 4. Now, even though they don't ask for these questions, they could have even asked you what is the point of intersection between the axis of symmetry with a positive gradient and your graph of your graph of f, and you would have to equate your two functions to find where those two graphs will meet. Right, so that is the end of the first part of this video, and we have successfully done A through E, and in the next upload I will be doing F.